Hello guys, welcome to Ramta Solutions and welcome to your lesson on grade 10 trigonometry. Today we are looking at solving trigonometric equations. By the end of this video, you will know how to find theta when given a diagram like this or information like given in this diagram. Okay? So without any waste of time, let's get into it. So we are going to try examples. So the first example will be, maybe let me begin like this. Finding the angle. Okay, let me say finding the angle. The example will be, let's say, given a triangle like this. Let's say our angle is theta. We are given this side here, which is 9 units, and this one here, which is 14 units. So the question says, find the size of theta. Okay, so this is a right-angled triangle. Since it is a right-angled triangle, you must then ask yourself, you can use the ratios SOHCAHTOA, right? Cosine, sine, even your tangent. But you using them depends on what information is given. So I'm going to say to you the information that's given here, when you look at this side here, we refer to it as the side adjacent to the angle. And this side here is the hypotenuse. As you can see, it is opposite the 90 degrees. Therefore, we can use the cosine ratio. So our answer will be, or should I say our answer? Let me say solution. I don't know if there's any difference, but it's okay. So we will say, because we are given adjacent side and the hypotenuse, we can use cosine. So cos theta is equal to adjacent over hypotenuse. That's what you know, right? However, we are giving their values. This is what is cos adjacent. The adjacent side is 9. What is the hypotenuse? The hypotenuse is 14 units long. To find theta, I will say theta equals the inverse. Okay, the inverse of 9, the inverse of cosine for 9 over 14. Okay, so on your calculator, you are pressing, if you are using Casio, you are pressing shift and cosine. If you are using sharp, you will press second function and cosine. Okay, so let's see, what is our angle? Let's see, it is correct to 2 decimal places. Shift cos 19 over 14, it will be 49.99 degrees. Okay, I'm leaving my answer correct to 2 decimal places. This is what you will be doing in your examinations. You always leave your answers correct to 2 decimal places. Okay, all right. Now, let's then head to the second example. So, this time around, we are going to find lengths. Okay, we are going to find lengths. So, the example will be, let's use this one here. Let's say this one here is 10 degrees. This is an right-angled triangle, but the angle here is 56 degrees. Okay, the angle is 56 degrees, and then the side here is x. As usual, the question will say, find x. Okay, it will say find x. So, should I draw it bigger? Maybe let me try to draw it a bit bigger. Yep, 56 degrees. Perfect. This is 10 units, and then this is x units. Perfect. So our solution, we are looking for x. Remember, you must ask yourself, what triangle is here? It's a right-angled triangle, so you will use cosine, sine, and tangent, or tangent rather. So, but to know which one to choose, you look at the information given. First thing first, what is the angle given? It's 56. Now, what are the sides given? I'm giving a side with units x and a side with units 10 units long, rather r. So with length x and length 10 units. So what is this side that is 10 units long to 56 degrees? It is the adjacent. Okay? It is the adjacent. What is this side here relative to this angle? It is opposite this angle. So as you can see, we have opposite and adjacent. That should tell you we should be using tangent. But the angle is given. What is this angle? It's 56 degrees. So 56 degrees is equal to opposite over adjacent, which is x over 10. In other words, x is 10 times 56 degrees equals x, right? Because you multiply by 10 throughout. So let's get our answer. 10 times 56 degrees. What is our answer? 14.83, which is x. Therefore, x equals 14.83 units. Even if you leave it like this here, it's okay. Of course, when you round it off to the nearest number, to the nearest whole number rather, or to the nearest integer, it is 15. But since that's not what you would normally do in the exam, let's leave it as 14.83. Okay? We're leaving it as 14.83. Okay. Now, let's take it now a notch higher. Now, let's now say solving trigonometric equations. Now, this is interesting. Solving trigonometric equations. Okay? So normally, they give you a domain. Okay? So, but I'm not going to give you a domain. I will just say to you, determine the angle, meaning I only want one acute angle. Determine the angle. Number one, we're looking at sine, let's say sine x equals 0.2. Number two, sine 2x plus 45 degrees is equal to 0.123. And then number three, tan 2x is equal to 3.125 degrees. And number four, we have 3 tan, let's say beta, or let me use x. Okay, let me use x. X, it's okay, let me be consistent. X equals 1. And then number 5, we have sine. We have sine x equals tan 45 degrees. When you come to this section of your question paper, you are supposed to use a calculator, so do not stress. Now let's begin with the first one. Our solutions. Let me use let me use the white, it's okay. Now our solution, number one, We said it's sine x equals 0, 2. Sine x equals 0, 2. What do? You will simply say x equals sine inverse of 0, 2, which is, let's see. Yep. So I found it. We get 11.54 degrees. Okay. 11.54 degrees. All right. Perfect. Now let's head to number 2. Number 2, we are then looking for, what is number 2? Okay, sine 2x. Sine 2x plus 45 degrees equals 0.123. So when we proceed, we'll say 2x plus 45 degrees equals sine inverse of 0.123. Let's see. Sine inverse of 0.123, what do we get? 2x plus 45 degrees equals, let's see, 7.07 degrees. Okay? Now, we are solving for x here, as you can see. So we'll say 2x equals 7.07 degrees minus 45 degrees. Right? Okay. So this will be negative 37.93. So 2x equals negative 37.93. But you are not done. You are looking for x, not 2x. Divide that 37.93 by 2. What do you get? You get 18. Let me see. Oh, by the way, did you round off? Oh, yes. I should warn you here. In the middle of a calculation, please do not round off. At least use about, let me see, at least use about, write the whole thing if possible, or use about 5 decimal places. So I will just say this is 7,065272931, which is 7,065272931 minus 45. Right? Oh, by the way, it's in degrees. Okay? Do not round off in the middle of your calculations. But if, for example, you are leaving your answer to 2 decimal places, maybe leaving in the middle of calculations, working with about 5 decimal to 6 decimal places won't really affect your answer. Even 4 won't really affect your answer. Okay? So let's just take it like that. So now when we minus 45 degrees, what do we get? We get 2x equals 93472,707, isn't it? Now, when we divide that by 2, we can now round off to 2 decimal places. It will then become 18.97 degrees, right? Because we have divided this by 2, so it will then become negative 18.97 degrees. Okay? All right. So the third one was tan 2x equals 3,125. I shouldn't have added degrees. I don't know why I added degrees here. 3,125. Let's see. Tan 2x equals 3,125. Now we have 2x equals tan inverse of 3,125. Let's see what it is. Shift tan of 3,125. Do we get? I got 2x equals, remember what I said to you, in the middle of calculations, do not round off to the required numbers, just maybe round off to 4, 5, 6 maybe, but I'm going to write it in full. 255,32837. Now what is our answer? Our answer divided by 2 is 36.18 degrees. Okay? Our answer is 32.18 degrees. Okay? Moving on. Number 4. 3 tan x equals 1. Number 4, we say 3 tan x equals 1. So what we do here, we divide by 3 and then we get, or rather that means we get tan x equals 1 over 3. Therefore, by saying tan x equals 1 over 3, we can now find x, which is inverse of tan, right? Inverse of tan of 1 over 3. Let's get it. Okay, what is our answer? Our answer is simply 18.43 degrees. Right? Perfect. Number 4, sine x equals tan 45. That's number 5. Sine x equals tan 45 degrees. Now, this shouldn't be an issue because you see tan 45, it's easy. You can press tan 45 on your calculator, it'll return 1. Right? If you like, you can say, or maybe let me proceed here. You can say it's, now we can solve for x. I'll show you what I wanted to do. You can say x equals this guy here of 1. What do you get? Sine 1. Sine inverse of 1. What can it be? Sine is 1 only at 90 degrees. So, okay. I will say at 90 degrees. X is 90 degrees. Let me not be lazy. Yeah, my calculator returns 90 degrees. So, something that I wanted to show you here was to say, you can simply say x equals sine inverse of tan 45 degrees. It'll return 1. Okay? It will return 1. So, there's this thing that you need to be careful of, guys. When you are doing these questions, do not just assume that whatever that you're doing is correct. Try to verify it. Let's verify. I'm going to start with number 1. Others, you may not even need to verify that. But I'll just show you with number 1 and perhaps number 2, just to see what needs to happen. So you said your x is 54 degrees. So do this. Sine, what is x? Put 11.54 degrees. Tell me what your calculator returns. My calculator returned something like 0.200, but hello, if I round it off to 1 decimal place like depicted here, I'm getting 0.2. Can you see that? Good. Now, I want us to confirm this one here. Sine 2x plus 45. We found the value to be negative 18. So let's confirm it. Negative 18.97. Let's confirm it. So sine 2 into negative 18.97 97 degrees, of course, plus 45 degrees. Let's confirm. Sine 2 into negative 18.97 close plus 45 close. What do you get? Indeed, you get 0.123. You guys see that? So at the end, whenever you're doing this, try to see if you are getting what is given on your right hand side. Okay, so this is how you solve trigonometric equations. We will have more of these questions later. So with that being said, I would like to ask you to please subscribe, like, and share with others. So bye bye.